Welcome back to Beginner's Breadboards, my electronics learning journey. Today we're looking at connecting the Arduino to 3 different I2C devices, and I2C is this inter-integrated circuit. So more importantly, what we're talking about is what is I2C, or also referred to as I2C. So this is a 2-wire protocol, and it's a communication system between a controller and certain target devices. This can be sensors, or in our case, we're using different displays. So we have a controller and then target devices that are the things being controlled. It works with 2 wires, so that's why it's called a 2-wire protocol. Those 2 wires are the SCL, which is the serial clock, and the SDA, which is the serial data. So between those 2 wires, you can hook up several different targets to one controller and control all of them through just those 2 wires. Along with this, each of the targets is also connected to VCC and ground, and so is the controller, but it's those 2 wires that are actually controlling all of the process. Some outdated terminology also refers to the controller as a master and the targets as a slave, but they are a controller and then targets. So each of the targets has a unique 7-bit address, and that's built in to each of the targets already. And so what the controller can do with that is address an individual target using that 7-bit address in order to actually control it. And that's how the protocol is built. In theory, you can have up to 128 of these different targets built onto the same 2 lines. So you could, in theory, have 128 devices hooked up to the SDA and SCL and control all of them with a single controller. However, once you start to add more devices to it, it can slow down the data transfers because of the capacitance and everything, and it can get a little messy. So you wouldn't have that many devices, but in theory, you can hook up several devices to the same thing. Using an Arduino as the controller, each device has its own library within the Arduino IDE. So we're using 3 different targets here, one of them being a 16:2 LCD display, which we've used before, an OLED display, as well as an 8x8 LED matrix. So each of these has their own library within Arduino that allows easier ability to control them. So the way the I2C protocol works is the controller will begin with a start bit that kind of wakes everything up. And then after that, it will go to an address with a read-write bit. So that is a full byte, 8 bits in total. So a 7-bit unique address and then a read-write bit, which tells the targets whether it is reading or writing. And then after that, there will be an acknowledge or a not acknowledge from the target. So if there's a particular address that's sent by the controller and one of the devices with that address is hooked up to it, after this with the read-write, that target will acknowledge the controller, pretty much telling it that it's there. After that address with the read-write and the acknowledge, we'll start a data transfer. So that's either reading or writing. Here we're using everything that's being written onto it because they're displays. So the controller is writing something onto the target. But let's say you had various sensors that could also be read. So data from sensors could be read from the controller. So that data transfer will happen in 9-bit frames. So there will be 8 bits of data and then 1 bit, which is that acknowledge or not acknowledge. Every time after the first time, that acknowledge or not acknowledge will come from the controller. So after every 8 bits of data being sent, the controller will acknowledge whether it received it or not acknowledge it. After the data transfer has stopped and that data has been sent, there will be a stop bit, which kind of puts everything back to sleep. So this is our circuit that we built. For ease of viewing it, we've put it all in a box. So we have our 3 different I2C devices here. These are our targets and their various different displays. So here we have the OLED display. This is the 8x8 LED matrix, and this is the 16:2 LCD display. So each of these have 4 wires in them. So 2 of the wires are for ground and VCC, and then the other 2 are for the SDA and SCL lines. Those SDA and SCL lines are connected to A4 and A5 of the Arduino here. And then they are all connected together within the circuit. So SDA and SCL all together there. So with the code, with I2C, there's a couple different things you can do. So this is starting with something called an I2C scanner. So let's say you don't know the 7-bit address for one of the devices or all of the devices. This scanner can show you what the different addresses are that are being present. So what this does, it'll send a start, and then we'll send the 128 different addresses that can happen, and then we'll stop. And it's just waiting for any one of the addresses to be acknowledged. If there's an acknowledge, it'll list it down that there is a device found at that address. So as this continues to run, we see we have 3 devices found at 3 different addresses, which are being written in hex. So this has its own code to it, and it's just using the I2C protocol. But it's a pretty simple thing that can just kind of be found, and then you can use this to find the specific addresses for each of the devices. So for our code with the 3 different I2C devices and to be able to control all of them, it's a pretty lengthy code just because, again, each device has its own library within the Arduino. So we have to define for each of the elements, and they each have their own thing that needs to be done. So we include all of our different libraries. We have screen height and screen width for the OLED, and then some other stuff for the OLED as well as the matrix LED, just to be able to set it up and to be able to use it. And as we continue going down, again, for the LCD, the matrix, and the matrix, we have to, again, define some things, set them up to be able to work. And again, as we just go down, so the I2C will address the different components one at a time, and then we'll write something onto them. So for the OLED screen, we're writing beginner's breadboards onto it. And then once we address the LED matrix, we have this code, which will allow us to draw an X on the LED matrix. We had to do some things here for it to be able to work. And then in between on that LCD display, it'll tell us what it's addressing at any given time. So it'll address the OLED display, then it will do that and write something onto the OLED display. And this is a little bit more code for, again, defining some elements within the OLED, being able to allow it to print on 3 separate lines. So now showing that everything works all together, we have our 3 devices. So the LCD display is telling you which of the other 2 devices it's addressing at that given time. So the LED matrix and now the OLED display. And so just based off of how we set it up, it switches between them. And then the Arduino as the controller will go through the full I2C protocol to address each of them and then write data onto them.